October 3rd, 2025, an interstellar object, 3I Atlas, brushed past Mars. Every spacecraft there, European, American, and Chinese, had a ringside seat. Within days, NASA's Perseverance rover posted a smudgy streak of light. The European Space Agency tweeted that they were gathering data. And then, from China's Tianwen-1 orbiter, absolute radio silence, not a single pixel.
This video is sponsored by Upstream. Want to grow your YouTube channel faster? With Upstream, you can run a 24/7 live stream using your pre-recorded videos. Since live streams rank higher in search, you'll gain more views, more subscribers, and more revenue. And it's not just YouTube. Upstream lets you multi-stream to up to 10 platforms, design custom layouts that match your brand, and schedule your content so your channel is live even when you're not. Sign up free today with the link in the description, and if you decide to upgrade, you'll get 20% off your first month. Start streaming smarter with Upstream.
Why would the fastest rising power in space go completely dark right when the universe sent us a postcard from another star? The silence itself is the mystery. Let's rewind a bit. This mysterious visitor, officially designated 3I Atlas, wasn't just any comet. It was first spotted on July 1, 2025, by the Atlas Survey, based in Hawaii, a network of telescopes constantly scanning the skies for potentially hazardous asteroids. But almost immediately, the trajectory math screamed something far more extraordinary: interstellar. Within mere hours, the astronomical community was buzzing. By the very next morning, it had earned a formal designation, making it only the third object ever to receive that coveted I for Interstellar label, joining the ranks of the enigmatic Oumuamua and the more conventional cometary 2I Borisov. Early spectroscopic analyses offered even more tantalizing clues. It revealed a faint tail composed of cyanogen and diatomic carbon, the kind of delicate, pristine chemistry you'd expect from a comet that had never, not once, felt the searing embrace of a star's heat. This wasn't some dusty old relic from our own solar system. This was a true virgin, untouched by stellar radiation until its recent, fleeting visit to our neighborhood. By August, every ephemeris, those crucial astronomical tables predicting celestial positions, pinpointed the comet's encounter with Mars for October 3rd, 2025 at precisely 1418 UTC, with a tiny margin of error of plus or minus 3 minutes. The distance? A mere 0.2 astronomical units from Mars. To put that in perspective, that's close enough that theoretically a good phone camera on the Martian surface could have picked it up, let alone the sophisticated multi-billion-dollar orbiters circling the planet. This wasn't a distant speck. This was a prime viewing event. Right now, Mars isn't just a planet. It's practically the busiest patch of real estate in our solar system outside of Earth itself. The European Space Agency, ESA, has had its veteran Mars Express circling the red planet since way back in 2003, a true workhorse. Its younger sibling, the Trace Gas Orbiter, joined the party in 2016, specifically designed to sniff out atmospheric subtleties. NASA, never one to be outdone, boasts an impressive contingent. The Mars Reconnaissance Orbiter, MRO, a high-resolution imaging powerhouse, MAVEN, dedicated to studying Mars's upper atmosphere, and of course the lone surviving rover pack, Perseverance, still trundling along, collecting samples and sending back incredible images. Then there's China. Their Tianwen-1 mission arrived in 2021, a remarkable feat of engineering that successfully deployed a rover. Sadly, that rover, Zhurong, quietly ceased operations in 2022, but the orbiter itself, it's alive and well, its solar panels soaking up the sun, and critically, it's packed with a high-resolution camera. This camera was and still is advertised to potentially beat NASA's legendary high-rise camera on MRO on a good day, offering unparalleled detail. All of these advanced eyes in the Martian sky were, without exception, alerted via the interplanetary network, our cosmic communication system, that a once-in-a-mission comet, an interstellar guest, was on its way. They all knew it was coming. They all had the opportunity. So what happened? NASA's first image was a comically understated 64-pixel smudge. ESA promised full-color images later after dealing with calibration headaches. Neither set the world on fire, but they showed us something. China? A perplexing zero. Their space agency's website posted about steady progress and lunar rocks, anything but the comet. Searching for Tianwen 3I in Mandarin gets you nothing. It's as if for China the event never happened. Now we get it. Space agencies, like any large scientific bureaucracy, love to stall. Data processing takes time, reviews are rigorous, and public relations are carefully managed. But in this particular case, 3 standard excuses that one might typically offer just collapse under even a minute of scrutiny. They just don't hold water. Excuse number 1. The data are still processing. Tianwen-1's main camera is a serious piece of kit capable of capturing 2.5 meter per pixel frames. Each of those images, uncompressed, weighs in at about 600 megabytes. Now, consider the download process. Data travels from Mars back to Earth, typically via X-band radio at a rate of roughly 2 kilobits per second to the Chinese deep space network dishes. Even with that relatively modest speed, the raw data from a few critical observations should have completed its journey weeks ago. We're not talking about a continuous stream of video here, but targeted observations. That excuse feels thin, doesn't it? Excuse number 2. The comet was too dim. At the moment of its closest encounter with Mars, 3I Atlas was sitting at approximately magnitude 11. For context, that's bright enough for a decent amateur telescope on Earth to spot even from light-polluted urban skies. Mars famously has no light pollution whatsoever. Its atmosphere is thin, its skies are dark. For Tianwen-1's sensitive instruments, designed to image the Martian surface in high detail, a magnitude 11 object should have been a clear, albeit swift, target. It wasn't exactly a faint whisper in the cosmic background. And finally, excuse number 3. There's nothing to see. This is perhaps the most self-defeating argument of all. If indeed there was nothing remarkable to observe, releasing a few mundane images, even blurry ones, would instantly kill the rumor mill. It would put an end to all the speculation, the whispers, the conspiracy theories. Instead, the profound silence from Beijing only feeds it, allowing the imagination to run wild. In the absence of facts, human nature fills the void with conjecture, and China's current strategy is practically an open invitation for exactly that. Here's the bit that really gets the astrodynamic geeks whispering excitedly in conference corridors: the strategic advantage Mars offered for observing an interstellar object. Catching an interstellar object from Earth, launching a probe to intercept it, or even just get a really close look, is an astronomical undertaking. It would require a launcher the size of a Saturn V, a behemoth of a rocket, just to get the necessary delta V, the change in velocity, to match the comet's incredible speed.
But from Mars, that's a completely different ballgame. From the Red Planet, you could theoretically pull off an intercept or a close flyby mission with a rocket in the Falcon 9 class, still powerful but significantly more manageable, combined with a 5 km/s kick stage. The math involved is brutally complex, yes, but it's absolutely doable. Every single space agency on Earth knows this. They know that whoever manages to map that trajectory first, whoever gets those crucial initial observations, essentially owns the mission design for any future follow-up. A few crisp images, just a handful of good data points, could be enough to nail down critical details. The non-gravitational accelerations caused by outgassing jets, its precise rotation state, maybe even hint at a tiny nudge that isn't natural.
If you were, say, planning a very quiet flyby mission, or an ambitious sample return, or, and let's go full sci-fi for a moment, an actual intercept mission, you would hoard every single photon, every byte of data, every scrap of information you could get your hands on. You wouldn't share it. You'd keep it locked down tighter than Fort Knox. China has a playbook for this. Say nothing, perfect everything, and only reveal your success when it's undeniable. We saw it with their Lunar Farside mission and their lunar sample return. It was months of operational silence, followed by a triumphant broadcast. Applying that playbook here implies one of two things. Either Taiwan One's data is worthless junk, or it is so incredibly valuable that keeping it secret is worth the international suspicion. The utter lack of even a defensive leak is what turns heads. All right, let's walk through the speculative doors, because honestly, that's probably why you clicked on this in the first place, right? The human mind naturally goes to the extraordinary when faced with an information void this significant. Door 1. Perhaps they captured a simple but utterly breathtaking image. Imagine twin jets of gas erupting from the comet's nucleus, glowing like landing lights in the Martian night. Such an image could reveal that the nucleus isn't a single solid object, but rather a contact binary or even trinary system, 2 or 3 smaller bodies gently touching, bound by gravity. That kind of discovery would instantly rewrite our current models of comet formation and evolution, sending ripples through planetary science. It would be a profound yet purely natural revelation. Door 2. This one leans a little more into the unknown. What if they observed a light curve, a pattern in its brightness, that absolutely refuses to obey the laws of gravity as we understand them? Tiny rhythmic impulses, perhaps, or subtle deviations that hint at something more than just natural outgassing. We have no concrete evidence, of course, but cast your mind back to Oumuamua, the first interstellar object. Harvard professor Avi Loeb still passionately debates the 6 to 8 millimeter per second push observed in its trajectory, a minute acceleration that some suggest could indicate artificial control. Could 3i Atlas have offered a similar or even more pronounced puzzle? Door 3. This is the ultimate, the one that makes your heart race. What if the comet demonstrably altered its course after periapsis, its closest approach to the Sun, exhibiting a statistically impossible delta V, a change in velocity that simply couldn't be explained by natural forces, unless, of course, something helped it? Any one of these scenarios, from the scientifically profound to the utterly mind-bending, would more than justify locking the raw files behind state-secret classification faster than you can say technosignature. It would be a paradigm shift, an event that forces humanity to reconsider its place in the cosmos. And it's not just China that's been quiet. The comet's arrival was inconvenient for the West. A U.S. government shutdown froze NASA's Public Affairs Office. ESA's communications budget was reportedly raided to deal with old data from another mission. The translation? The usual watchdogs were distracted and understaffed. In that vacuum, an ambitious player could exploit the situation. It wasn't necessarily a conspiracy, but a convergence of circumstances creating a perfect window for strategic silence. But the universe doesn't wait. 3i Atlas is now hurtling away past the orbit of Jupiter. Its brightness is plummeting. By March 2026, it will be fainter than Pluto. Every day of delay erases the chance for follow-up observations from Earth or even the James Webb Space Telescope. The longer China remains quiet, the greater the scientific loss for all of humanity. This isn't just suspicious silence, it's actively wasting invaluable knowledge. So what can Western agencies do? They could share first. Imagine if ESA or NASA dropped their complete unadulterated image sets tomorrow. The cost for China to remain silent would skyrocket. But they haven't, and that hesitation is telling. Perhaps everyone's data is truly stuck in processing, or perhaps everyone is a little nervous about what the pixels might actually show. This collective reticence only deepens the enigma. So what do you think is sitting on Taiwan One's solid-state drive right now? Is it just a routine, albeit interstellar, comet offering nothing particularly groundbreaking? Or is it a cosmic changer, a profound discovery that forces us to rethink our place in the universe? Or perhaps even more tantalizingly, something so utterly unprecedented that humanity doesn't even have the vocabulary for it yet? Don't hold back. Drop your best theory, no matter how wild, no matter how speculative, down in the comments below. And if you want the download link the absolute minute any agency, east or west, finally blinks and releases more definitive data, make sure you smash that subscribe button. Interstellar objects are cosmic subpoenas, forcing the universe to reveal its secrets. 3i Atlas delivered its subpoena to Mars in October. NASA scribbled a quick note. ESA filed a draft report. And China slipped the envelope into a vault and walked away whistling. Until Beijing opens that vault, the silence is historic. Somewhere, a hard drive holds photons that left another star system millennia ago. Secrets this big always have a half-life. One day, that file will drop, and we will finally discover if we met a messenger from another star or if we simply chose not to answer the door.